Hi, everyone. Thank you so much for the opportunity to talk about this super critical area. My name is David Aronchick. I'm CEO of a company called Expanso. Our job is to make it easy to run your data pipelines anywhere. That's cross-zone, cross-region, cross-cloud, all the way to edge, on-prem, and IoT devices. Help you pull your data in. And it's very much in line with what I'm going to talk to you about today. My background is I've been in data and machine learning for quite a while. I was the first non-founding PM for Kubernetes and it started a project called Kubeflow, which has been doing machine learning since 2017, which feels very recent to me, but I guess is like old times in machine learning ages. And since in both of those cases, I kept seeing this situation where it's like we have all these amazing tools, but they're really built for, oftentimes just data engineers' laptops. But maybe if you're lucky, they were built for a centralized data center or data warehouse, and those are great. Doesn't mean you should throw those away. But if we're going to get to the future of data engineering for machine learning, this presentation is a little bit of discussion of the things that you need to think about. So the biggest problem I think in machine learning today is what I call the ingested all tax. Like, what does it mean when you sit down and talk and look at trying to ingest everything before you even begin looking at it? And I'm going to talk about, why I think this is a problem and what we can do about it and why this is rearing its head now. And then we will talk about some of the things that I think people need to be thinking about, including open source ways to approach the problem. I'd like to offer this. This is no joke. If you want $50, I am happy to spend an hour with you. That means not you paying me. I will pay you $50 if you come and talk to me about your data strategy. This is something I put out there because I love talking to people about this. I'm writing a book as well as my company. I'm not going to try and sell you during that time, but come by and try and book my time because it's so important to me to actually hear what you're going to do this. And if you miss this QR code, it's coming later, so just get your phones ready. So I always like to start with an uncontroversial statement. Data, it's getting bigger. It's pretty standard. Like, I think that most people can agree with this. And you're like, okay, well, fine, it's getting bigger. What's the problem? We got bigger pipes, bigger disks, bigger everything. The problem isn't that it's getting bigger. It's getting bigger faster than the systems that were built to support it. This year, we're supposed to handle 175 zettabytes of data, according to IDC. That's with a Z. And, it's so big. And even though I give this talk or show this slide all the time, I still can't even remember. It's like, I think it's tera, peta, yada, zetta. So it's like 2 bigger than peta. But it does a lot and it's growing everywhere. And one of the things that's really interesting is that these second 2 points, which is one, 60% of it is unstructured and generated outside of your traditional data center. And second, Gartner says that 73% of them, enterprises, can't keep up. And this is already the case, right? And it's just growing faster than ever before. Number 2 is that the data is noisy. Gartner estimates 29%, just 29%. That's of data is that even accessed for any business function. So you're moving 2/3 of the stuff you're moving, you're not even using, you're not even looking at it, which is again just kind of crazy. And then finally, data is hard to centralize, and it's because of those first 2 statements. What you have this situation where the data is so big and you're moving so much of it that is not structured, not formal, that you're going to end up with situations where you're overwhelmed. The pipes and the systems are not fast enough to receive it. And even if they are, they're not fast enough to process it. And, we haven't even gotten to the fact that if you move raw or unstructured data or things where you have PII, personally identifiable information in it, you may be actually violating the law. So it does get even worse than that. And that's what I call the ingested alt tax. And the biggest reason here is we apply control over this data too late. You wait until you get to your central archive, your data repository, your S3 bucket, your bronze tier, whatever you call it. And you are doing this in such a way that you're only applying data controls when you get to that phase. And again, I get it, but it's just not the way the world works. You're creating waste, you're making things unstable, and I'll tell you how that we're doing that in a minute, and like incredibly long iteration cycles. So then you're like, well, if it's not AI ML, let's party here. What are we going to do? All such a mess of stuff. And forgive me, I'm not. I'm talking right now. I will look at comments in just a second. What I would argue that this is an ML problem. This is a machine learning, an AI problem, because the supply chain, the lifeblood for making AI and ML useful, whether or not you're doing training or you're doing inference, that means you're taking the data and you're handing it to a machine learning model, even a hosted one. If you're not doing upstream control, you're leaking regulatory confounded information. You are often moving raw data, or you're applying too much context. So if you hand one of these things, these endpoints, a very, very large blob of data without structure or so on and so forth, it's going to appear badly. And you're probably you're not also simultaneously, you're not moving enough context. Because a lot of times you might have like a random IoT sensor, and I'll get into some of this in a second, or a point of sale system, or a record from a patient that doesn't have the additional context that AI endpoint needs. And so this is where applying control and upstream transformation of your data is so critical. And at the end of the day, it hurts in every possible way: trading costs and governance and model quality and result quality. So I like to say that we need a modern path for modern data processing. In this case, you have all these wonderful tools over here on the right, and I can't stress enough, the tools are fantastic. Don't get rid of them. They have spent years and years, decades in many cases, getting these platforms to be spectacular. But it's the stuff on the left that they kind of leave as an exercise for the reader. What is going on? Everything, to the question marks and left: multi-region, multi-cloud, edge, IoT, on-prem, embedded, or maybe none of those things. Maybe it's just virtual machines running, outside your data warehouse. How are you getting that data into your data backend, where you're going to use all these centralized tools? I'm just going to take a second here. Yes, I couldn't agree more. The question was around underserved hospitals, colleges, Department of Corrections, et cetera, et cetera. Basically, if you are touching customers or users in any way, it is your responsibility to talk to them, to manage them, like carefully, judiciously, being thoughtful, simply taking that data raw from whatever it is. Could be a manual entry point, could be HR system, could be anything. You want to get it into your data warehouse. That is the right thing to do. But do not upload it to your bronze tier without applying some control, without applying an audit log, without applying lineage. And before you freak out and say, like, my God, this sounds impossible, I promise you it's not. With the tools that I'm going to talk about today, and again, I'm happy to counsel you through, not as a commercial person, just like talking to you about how it would work. We can absolutely help you do that. We do have a platform that helps make this very, very easy, but truly, I want to help people regardless of what they use. So what I'll say is that, the timeline to getting us here, especially in the Python, PyData community, is really well understood. First, we started and said, building data tools against data is hard. That's where Pandas came along. I think it's spectacular. Then running jobs took forever, and that's where things like Dask and Spark and Ray and others came along to really help us solve for compute that was spread across multiple clusters. Then it was like accessing my data is too slow, and that's where things like Arrow came along to do in memory and much more sophisticated things around that. And now we're at this point, right? Okay, I have compute, I have the tools, I have notebooks, I can now access my data at speed. However, I need to fill my data stores with clean, well schematized, secure, reliable, tracked data that represents every part of my business. I can't just say like, okay, well, hey, this stuff is being generated on whatever, Salesforce or ClickHouse. Great, that's great, but how much of that business does it actually represent? And I bet if you look at it, it's probably 20% or less of your data. I bet the majority of your data is coming from somewhere else. Gross CSV files, Excel, PDFs, point of sale systems, temperature sensors, whatever it is. And I talk to people in every industry. The majority of the meaningful data is being generated outside their data warehouse and somehow being lifted in. And in some cases, that's good, but in most cases, it's not. And this is where this is what I call the ingested alt text. So we need a new playbook or playbooks. And what we do is we focus on the facts. I like to do this. There are certain things that just are never going to change about your business, about any business, because this is the way that physics works. One, data is everywhere, not a dispute. So we need to be able to store and query the data where it's generated. Second, the speed of light is constant. Not a very controversial statement. It's been constant since the dawn of the universe and appears to be constant this point forward. So we need to be thoughtful about what we move, when, how. Knowing that latency is going to be an issue in 10,000 years, latency will be an issue because you just can't get any faster. And then third, regulations and data gravity exist. There's lots of data you should never move. You should probably never move a raw social security number. You should probably never move a raw email address or IP address or anything like that. These are things that create more exposure for yourself, but really make it very dangerous for your customers. And this can be a challenge as well. Again, I do want to offer, if you want a strategy session and be paid, here's the way to do it. So let's talk about this. Playbook number one, data is everywhere. Your data, like I said, it's being generated everywhere. Moving it all is costly, is unrealistic. You have slow egress costs, you have slow queries, you have a lot of operational overhead. Simply moving this data can be, overwhelm most data pipes. I was talking to some satellite folks who have petabytes of data. And I said, even at let's say you have two machines inside of a data center in Oregon, and you're operating at, generally speaking, the fastest you can possibly move data inside that organization between virtual machine to virtual machine. A petabyte of data at that speed, 10 gigabits, takes a week and a half. Full bore, nonstop, etc. Like simply moving that data is just not going to be possible, from machine to machine without some form of intelligent way to approach it. You could shard it, you could split it out, whatever. But what you can't do is magically get, bigger pipes out to sites and on-prem and cross-zone and cross-region. And so playbook number one is be thoughtful about doing store and query in place, right? Again, that doesn't mean you leave it all out there, but what can you do with your query to move it to those locations? What can you do to selectively move your data in? You can use things like federated pipelines. I do want to be very clear, federated training, federated queries. This is really advanced stuff. Be thoughtful about whether or not you need it. You may not, right? If you say, hey, okay, I have a airplane hangar in Alabama, and it is generating, airplane engines generate about 20 gigabytes of log data per flight hour per engine. And each one of those things lands and downloads it to that warehouse. Do you need to move all of it? Probably not. Actually, it's probably okay just to store it there. And then run a processing job over that thing in place and move a selection, aggregation, a batch, or whatever from that amount of data into your central data warehouse. It doesn't mean you don't move the rest of it if you need it, or you don't leave it there because and do non-federated work. That means call down into that location and get the query back. That's okay too. But what's important is to just be thoughtful about what you're moving based on what your needs are. There are lots of tools out there, open table formats, I mentioned federated queries, and there are open tools for that, Trino and DuckDB, and in-memory transport makes accessing things much faster than ever before with things like Apache Arrow. These are all open source projects that you could go and download and use. And so what happens here is, this is a retail example where you might have, poorly structured IoT out information at retail and so on. It is, unreliable connectivity, not because people are bad at their job, but because physics and because of cable modems and DSL lines and 3G towers just makes this unreliable. And then you're storing too much data and processing it badly. So what we recommend is a pipeline like this. Again, this is something where we can help you solve this at Expanso, but again, you can do this yourself, where you take your IoT data, you store it in a open format, Parquet, Iceberg, whatever it might be, and you assign some what we call near compute. And this is something where it allows you to execute jobs either manually against these by having someone on site do it, or having a centralized person issue a query to that location. It still lands in the same ETL, still lands in the same data lake, but it's reduced, it's filtered. And this is just absolutely critical. We can help you manage and maintain those tables, but like I said, there are plenty of open source tools. I don't want to make this a commercial exchange, but I am happy to talk about it. And then your data developer can issue queries out to those locations and query them in place. And they don't have to be federated. They could say, okay, I want to go issue this specifically to Alabama because I have a question about that. And like I said, if you want help thinking through this strategy, I will pay you. Second is speed of light is constant. It's kind of a funny phrase, but it's true. In 10,000 years' time, the ping time between LA and New York, assuming those cities still exist, will still be 49 milliseconds. There is no way that's going to get any faster. And so anything that requires even remotely real time, and people are like, oh, well, I'm not, using this a remote device to brake my car or anything that might require that. Well, it turns out that when you start to ping back and forth, 10, 100 times in order to get your app working or whatever, and you're separated by that far, congratulations, you've now eaten 2, 3, 4 seconds of latency, not just 49 milliseconds, because you keep pinging back and forth. So it's not something you can just dismiss, even if you're not in the academic real definition of real time. I like to say, you cannot make a decision faster than your data can travel. If you're waiting for it to arrive, you've already lost. And so the second option is to store and query. Excuse me. Oh, I got my heading wrong here. I gotta fix that. But it's basically process your data locally at the source, ship the answer, and give yourself the ability to do real time, in place. So that's not actually from a central location doing the work on this. It's in fact empowering your remote locations to take action. That doesn't mean we need, automation and drones and all those kind of things doing all this work for you. But if you can be thoughtful about, hey, you know what, this machine has now thrown 3 500 errors in under a minute. I'm going to actively remove it from the load balancer, right? That is an action you can take. It doesn't mean you're like doing crazy things. You're just saying, okay, something else in that cluster is going to pick up the load because something is going here. This also, by the way, can be an enormous way to slash costs. More often than not, centralized data warehouses charge a lot more money than just running a generic VM or a machine that you own yourself. Again, that doesn't mean you're getting rid of that, but it means you're using those central repositories and clusters for what they're good for. And to achieve this, you can do things like edge data agents in place. You can use things like stream processors and things like that, or embedded query engines. But the point here is having the tools and functionality at the edge that are flexible enough to handle all the scenarios that you're trying to tackle. So before, it might look like this. You have a bunch of machines out there in a bunch of different locations. Each machine is doing what it does best, serving API endpoints, serving data, serving whatever you'd like. You're pushing your raw log data. Maybe you're doing it batch, maybe you're doing it streaming. Every whatever, 1 minute into your backend data warehouse. It lands in an S3 bucket or S3 compatible blob store of that kind. This gets handed to high throughput compute, which ultimately lands in your final data warehouse. And most systems are set up that you can't even take action till it lands all the way here on the right, at your final data warehouse, because finally it's been aggregated and pulled, and your systems are set up to study this and look for anomalies over here. But you've had to go through all these steps along the way, which, in the best case is minutes. And for many, many people, it's hours or daily or weekly or things like that. And that just means that you're having to act very, very slowly. Now, again, that's not the entire problem. One of the additional problems is that you might be shipping raw, unsecured security violations. The log4j security vulnerability, no shame on them, this stuff happens, was specifically because of this. People were shipping raw query data from these remote locations into a central ETL high throughput pipeline and processing the log4j, using log4j, and ultimately having an attack vector into that because they hadn't done any sanitization before that. You can apply sanitization there, but wouldn't it be nice to apply sanitization up front and ensure that your data pipeline is clean along every step? So our solution is to instead run agents on or near these devices themselves, just like another log shipper, but give you the capabilities to aggressively apply data engineering at the edge. That doesn't mean you're getting rid of. You notice here, I keep saying the remainder of your pipeline remains untouched. It still works great. Please keep using it. But you apply some data controls, schema analysis, structure, filtering, so on and so forth, before transporting. And because you're doing that, you're moving less data and everything is getting faster. It doesn't mean you're throwing it away. Simultaneously, you can still move this stuff off to archival storage, where it is treated as untrusted external to your organization. It doesn't make it into your central data warehouse until you are ready. But if you need it for audit purposes or others, you can still do that. And like I said, I'm a little bit short on time, so I'm going to zip through some of these things. What I will say is that this is a real architecture that we talked with a customer about, where they were spending more than $2.5 million a year on log collection. And we were able to show them a playbook where we cut that to $18,000 without losing a single byte of data. Just this. Now that required a slight re-architecture to do that, and they ended up spending more than that, not on us, interestingly, but because they had some other requirements that they were like, well, we need this to be a little bit faster throughput, so we're going to still spend on this, but let me rest assured that it was not $2.5 million that they ended up. They saved an enormous amount of money just by implementing a system like ours. Again, I want to stress, and I'm going to show this QR code one more time. Please reach out. I will pay you. It's free money. And then finally, regulations and data gravity exist. Again, not terribly controversial. We all know about it, things like GDPR and so on. And like I said, your data warehouse, what you want to avoid is that being toxic in any way. To have untrusted data, make it into anything, even your bronze tier, is a disaster. Be thoughtful about what you upload. Still use medallion architecture, still use the type pipelines and things you've already built, but don't just use a generic log shipper to get the stuff there. Be thoughtful. And one of the things that I think is going to be a real tsunami of pain is what I like to call reactive auditing, where it's like you get an audit request from regulatory body or your internal legal or your CIOs, and you simply can't reconstruct where the data even came from. Are you even tracking that lineage? The solution here is to apply policy at the source, and I'll share all the slides. This is a little bit longer, but you get the idea. It doesn't mean it's hard. Applying policy at the source looks something as simple as this, right? You have a file, you do a transformation, maybe you hash the PII in a simple filter here, and then you put it into your sinks where you have an S3, and then you have a raw backup log. By the way, this is a real this is a little bit simplified, but this is an example that I took from our examples on Expanso. This is how easy it is to apply a pipeline to your data upstream. But this is what it looks like to apply policy upstream. You simply say, hey, I'm still going to ship it to my S3 bucket, but before I do that, I'm going to filter and I'm going to obfuscate. Open Policy Agent is also excellent here. Strongly recommended. It's in the Linux Foundation now. Tools like Vector and Benthos are great as engines that apply upstream. And then, like I said, I'd be remiss if I didn't mention that we do offer something here that is fully compatible with all these open source tools, where you have a control plane that operates upstream. Ours is called Expanso. Like I said, I'll zip through these, but basically the idea is if you are waiting, either you're saying, oh, I have a split pipeline or I have a split database or so on, I'm just going to apply controls there. The moment you move the data out of these zones over here on the left, you are normally already at risk. And if you'd like to know exactly how at risk, let me pay you in order to ask that question. This is the last time I show the QR code, but I am available on all the socials and so on. So the summary is, ingest it all. It sounds like a good story. It's fraught. Be thoughtful. You want to shift control upstream. You want to use an open source playbook to do so. There are many great tools out there, and we do offer full compatibility with these things. If you'd like to work with someone who's processed literally petabytes of data for customers, we are happy to help. But the result is, it really is, 1 + 1 = whatever, 17. It's cheaper, it's faster, it's more resilient, it's more secure, it's etc. Yes, great point, Marco. Here's a GDPR point that I love to tell everyone. IP addresses. If you are moving a raw IP address today, talk to your lawyers, but our lawyers say you are already in violation of GDPR. A raw IP address. Honest to God, do not move it. Be thoughtful. Add a salt, just like Marco said. Make sure it's secure. Make sure it doesn't. At that point, it really doesn't need to be retrievable, right? So do it. Make sure it's one way and go to town. But yes, be very, very thoughtful about moving anything that could represent your customers, and I'm happy to talk you through that. And finally, that's me. You can see all the places to reach out. We're on LinkedIn, we're on Blue Sky, we're on Twitter. We have websites and names, and then of course myself. It's just, if you want to look for me, my last name everywhere on all these places: LinkedIn, Blue Sky, and Twitter. Feel free to reach out. I love talking to folks, and like I said, I'm also writing a book, and I'm always happy to hear how we can help, or how I can make this message more resilient and meaningful for everyone. And with that, that's my time. I have a couple minutes here for talk, but you tell me. Yeah. Any other questions? Go be fruitful and contribute to your upstream open source projects. Your open source maintainers will thank you. File thoughtful bugs. Don't just say this doesn't work. Tell them why. Give them context. Again, I'm a Kubernetes open source guy. I'm a huge fan. I'm a Python person. That same offer for filing bugs cannot be overstated. All right. Well, thank you so much, everyone. I really appreciate the opportunity.
Thank you so much, David, and thank you so much to the attendees. We can keep the conversation going in the Discord. And you have a wonderful day.
Thanks, everyone.
Bye.